Hi guys, let's do reverse vowels of a string. So we're given a string S and they want us to reverse only all of the vowels in the string and return it. And they say vowels are A, E, I, O, and U and they can appear in both lower and uppercase letters more than once. So in example 1, we're given this input string, ice cream, and then we would output this because the vowels in S are these. And then once we reverse the vowels, then S becomes this string instead. So like the I and the A switch, then the E and this E switch, and then that is it. So that's what happens. And then in example 2, we were given input string S equals LeetCode, and then we would output this because basically the first E and last E would switch, and then this second E and the O would switch, and those are the only vowels. So this is the output string that we would get. So for this one, we can initialize a hash set that contains all of the possible vowels so that we can have a O of 1 lookup to see if a certain character is a vowel or not. And then we can have two pointers that go through the string, so one at the start and one at the end. And then we're going to work our way inwards. And then every single time we're going to increment the left pointer and decrement the right pointer until we get to the middle. And then we'll return the resulting string. So like every time we encounter a vowel, then we'll swap those elements and then we'll increment and decrement. And then if we land on a vowel on one but not on the other, then we'll like leave that here until we reach a vowel on the other side too. And if they're both not a vowel, then we can just like move them both, because like we only want to keep it here if it's a vowel so that we don't lose track of it, if that makes sense. So let's start by initializing our hash set. So we'll say set of characters set equals new hash set, and then we'll say arrays dot as list, and then we'll put all of our vowels in here. So this is like a trick to initialize a set that already has that already has elements in it to start with without having to manually add every single element one by one. So we'll say capital A, lowercase a, capital E, lowercase e, capital I, lowercase I, capital O, lowercase o, capital U, lowercase u, and that is it. And let's move this over so it's not pouring into the next line. Okay, then okay, so the other thing actually is like, so since we're given a string here and we're sort of modifying a string, right, we don't want to have to modify the string every single time we encounter a vowel, because that's going to result in a terrible space complexity, because every single time we modify a string, we're actually creating a new string because strings are immutable. So we're going to want to use the string builder instead. So we'll say string builder, we'll just call it str equals new string builder, and then we're just going to use this to build our new string, and then we'll convert it back into a string to return at the end. That way we don't have an atrocious space complexity. So then we'll initialize our two pointers. So we'll say int left equals 0, int right equals s dot length minus 1. And then we will just keep iterating through until we reach the middle. So that's going to be when left is equal to right. So we'll say when left is less than right, then we'll keep iterating. So then we'll set char L to s dot char at the left index, and then char R will be s dot char at the right index. And it doesn't really matter. I'm just using s. Well, actually, yeah, we want to loop through s because our string builder is currently empty. Like, we're just going to be... Actually, no. I forgot. So we actually want to... Yeah, so we're just copying this string over. It's not empty, because when we copy this over, then we're just going to modify it directly. So yeah, so we're not like adding on to an empty string or anything like that. So... yeah, but like S and string builder, the string builder are the same thing, so this is whatever. You can do either one. And then, let's see, so then, okay, now we're going to want to check, so at every single iteration, we're going to want to check if the character at our current index is a vowel or not. So if both of them are vowels, then we'll swap them, and then we'll increment left and decrement right. So actually, let's just go ahead and do that. So we'll know if it's a vowel if the set contains it. So if set dot contains L and set dot contains R, then we know that our current characters are both vowels, right? Because that's at the left and right indices. So if they're both vowels, we'll just swap them first. So we'll say char temp equals L, and then stir dot set char at left to R, and then dot set char at right to temp, so that we don't lose the value. And then we'll increment left and decrement right. Okay, and then our other possible case is that our set contains L, and if it contains L, but it's not L and R, then we know it can't contain R. So that means only the left element is a vowel. So if that's the case, then we'll decrement just the right one, and we'll leave the left one because we want to keep that pointer there until we reach a vowel on both sides. So then otherwise, our set contains R, so the right one's a vowel and the left one's not, then we will increment left. And then else, then neither of them are vowels, in which that case, then we'll increment left and decrement right, because we just want to keep going until we reach vowels on both sides. So left plus plus, right minus minus, and then we'll just do this for every single character. And then at the very end, we can just go ahead and return stir.toString. So we'll just convert this back into a string, and then that should work. So let's see. All right. So the time complexity here. So let's take a look. We have just this while loop. That's our only loop here. Everything else is constant. So in this loop, we start from 0 and length -1 and work our way to the middle. But we're traversing through both the left and right side until we reach the middle. So we end up visiting every single character in the string exactly one time. So that's going to be O of n, where n is the length of the input string s. And then our space complexity, so we have two things going on here. We have our set, which is constant because it just stores all of our vowels, which is just the same amount of characters every time. And then we have our string builder, which will store O of n, where n is the length of s, and that is our only other data structure. So we'll say O of n is length of s. And that's it for this problem. Thank you guys for watching, and I'll see you guys next time. Bye!